Whoa, that's bright. Hello, Midnight Coders, and welcome to a new series where Prof and I are going to do a little bit of this, a little bit of that. We're going to explore some stuff and see what happens. Also known as FAFO. Uh, Mess around and find out. That's what we're doing here today, folks. We are going to mess around and find out. There is no polished tutorial. There's no real expectations. We cannot guarantee things will work. This is purely off the cuff, hard knocks learning as Prof and I explore as developers technically do. And just so you can see why my face looks like Casper the Ghost, let's share the screen and introduce our Prof. He will be doing majority of the heavy lifting here as we find out. Where am I at? There we go. All right, we are now on his screen. We are looking to explore a little bit of C++26 new feature, uh, the STD execution, I believe. Looking to do a little bit of concurrency and find out how exactly C++ plans to handle asynchronicity, I believe. If I have that wrong, Prof can correct me. But he is also deeply locked in right now. Once we have an understanding of what it is that we're doing as we study this developer in the wild as he does his natural thing, we shall take note and watch like a hunter in the wild. I can't even make this shit up. Oh no. Oh no. The stream has ended. We have lost a prof. And prof. Okay, there's
You
prof. I can hear you now, prof. I can hear you now.
hear me? My mic broke. There we go.
Okay.
Yeah. So
I was wondering why
basically,
you were. I was wondering why you weren't talking, and I was feeling like, what the hell's going on? Did
yeah,
you leave me? I just thought
yeah,
you were really
yeah.
locked.
Here,
I just figured you were really locked in, dude.
yeah. I'm about to be really locked in, but let's at least tell the viewers a little bit about what's up.
Yes,
Um,
please, because you can explain more than I can.
yeah, I mean, this is just async 08, the classic thing from JavaScript, C# and all the high-level languages, but in C++. And with C++20, I can show the viewers we have C++ coroutines, which are one of the least understood features, in my opinion, of C++, but also one of the most powerful ones. Because these coroutines
I think it's
simultaneously
least.
model.
I think there's a lot more than just C++ devs that don't fully understand coroutines.
Yeah, it's a very tricky thing because while this is technically speaking a language feature, the library support for this particular language feature didn't exist. So in C++20 we got stud generator, which is the tiniest imaginable bit of support for coroutines. Here it is. And it's a very simple thing. And now in C++26, we're supposed to get an actual asynchronous runtime support. And the reference implementation I'm going to be looking at now is by NVIDIA.
I
Their
just
NVIDIA
posted that.
StudExec.
I just posted that in the comments or the live chat. If anybody is watching the GitHub
Yeah, if
for
anyone is
NVIDIA.
watching and wants to work along with us, this is the CMake file you need. I use basically the documentation on how to add it. So this is basically the CMake package manager. I include that into the project description. I add the studexec package and I link it against my main executable. So, and just for testing purposes, here's a small program. If I go into build and I make it It runs. Okay. So my environment is set up properly. That's all I'm saying. Now, before we get to any programming whatsoever, we're gonna take a read through everything and try to do this properly because documentation on this is very sparse. So, Stud execute an experimental reference implementation of a standards model for asynchronous programming proposed by P2300 Stud execution and accepted into the C++26 standard. So this is gonna be the C++26 standard. I have the proposal right here, I think. Yep. Is that it? Yep, that's it. Okay. And they added, of course, their NVIDIA specific thing, but this is basically the simplest program. And I'm gonna actually just start by copy pasting that into this file. There we go. Like that. Take a look at that.
If you can paste that that link for the standard into Discord for me, I'll share it to our viewers.
It's all on the NVIDIA GitHub page, so just follow
Oh,
the
okay.
NVIDIA GitHub page.
There you go, guys. It's already there.
So you can see that all the links which are linked at the bottom of NVIDIA's page. So right here. This is where I took it from their resources. So let's start just by seeing if it even works. And there's a non-zero chance it doesn't. So make this J32. It built it. Okay, it runs. Wait, I didn't save it. Okay. Make.
There we go.
Okay, it worked. Let's run it. And there we go. It works. Okay. So let's dissect it. So here's what's up. So exec is the new namespace. So we create a static thread pool. Is there any? Oh, I don't have LSP start lang. There we go. So here we have exactly. There you go. So it's a static thread pool. Do we have any documentations now? Would be nice to take a look at some documentation, actually. Let's see. Anyway, so static thread pool of 3 workers, right? Then we get the scheduler for that. I would like to know what this auto is. Okay, so the auto is a scheduler. And scheduler is in studexec. Okay. Auto means it's not specified. You're not supposed to know what exactly the type is. Okay, makes sense. This is kind of like an interface. And the scheduler, yeah, it doesn't tell you what it is. Do I need auto?
So
Yeah.
is
Okay.
auto similar to var in Java, where it just
Yeah, it is exactly the same as var.
okay, just so I understand.
The stud scheduler here is an interface, so they're saying this var satisfies this interface.
Okay.
That's all there is to it. So let me take a look. So concept scheduler. Here we can see what that interface actually says. So it should be callable. What is that? Requires. Okay, so it just takes a scheduler, schedule type, and a scheduler's argument. Quality compare, no remove. Okay, so it's basically something which can be called with. Yeah. Okay. For now, that's it. So okay, so we create a lambda, which is the work here, just squares the number. Okay, so let me see if I can replace. Oh my god, the fuck is this?
What just happened?
I got sexpert all over.
Damn.
When all type. It should be a when all t. Wow. This is something I'm not understanding. Okay. Do we have like some sexpert? Oh, it's an expression. I have no idea what it is. Okay, so I'm gonna add a to-do here, read the documentation on this. Because I don't understand what the return type is. But apparently it's just that when all, and then it says, okay, so stud starts on, what does that do?
When all. I wonder if that's something that is sort of like a completable future, but like when they're all done and forward
Yeah,
together. Are these supposed to be
it looks like it.
that's what it makes me
You don't.
sound like this is everything when all of these things are
Okay.
done, return the results of them all,
Yeah, it looks like it.
I think.
Okay, I think. Okay, I think this is the point at which we start reading the any documentation whatsoever because like I'm confused. So let me get the documentation over here, and here I am gonna go to the user side the documentation because I'm a user.
I'm a
So
user too.
let me zoom. Yeah, let me zoom in. There we go. So an execution resource is a resource that represents the place where execution will happen. It could be a concrete resource like a specific thread pool object or a GPU, or more
Okay.
abstract one like a current thread of execution. Execution contexts do not have a representation in code. They are simply a term describing certain properties of execution of a function. Okay, so they don't exist. A scheduler, which we had, right? So we did have a static thread pool scheduler. A scheduler is a lightweight handle that represents a strategy for scheduling work onto an execution resource. Since execution resources don't manifest in code, it's not possible for a program to directly program against their API. The scheduler is a solution to that problem. The scheduler concept is defined by a single sender algorithm schedule.
Okay.
Interesting.
Which
So scheduler concept. So this has a sender. What?
type static scheduler. What is this?
I have no idea. Go back.
Okay.
Maybe the LSP can do some heavy lifting here. What happens if I do like sketch dot? Oh, there we go. There's our schedule method.
Okay.
So where we are, we're in static thread pool schedule, which returns a sender. Full queue thread. What? Okay.
Okay.
Anyway, that can go away. Let's keep reading. Oh no no no.
Where were we?
Okay. So that's a schedule. Okay. A schedule is okay. Schedule, which returns a sender that will complete an execution resource determined by the scheduler. Okay, so here's part of me thinking. So if schedules work, then can I not take this work and
Forwards and so according to that, each sender is a scheduler on Sketch using yada yada yada. Oop, I was reading the document you had
oh,
in
sorry.
the code. I was reading the document you had in the code there. So
Uh,
sender that starts with just n that creates a sender that just forwards n to the next sender after just
okay.
n. We chain them. Okay, so one sends to another send. Okay,
Yeah.
and then we just chain them all
We're
together.
gonna get to that in a sec, I think.
Okay.
So let me just finish the scheduler. So scheduler just schedules. So
logic that Logic that you want to run that context can be placed in the receiver's
with
completion.
completion signaling
The
method. What in the fuck is the
fuck is a
completion signal? Okay,
completion
well,
signal?
I
Yeah.
guess we're gonna find out what that is.
At least I didn't. Okay, I thought I was the only one that had that question. Okay.
Yeah, I have no idea. Okay, so execution scheduler, we create a schedule and we get a sender which is just scheduling itself. What?
Is of the scheduler. You schedule the scheduler, so you build the scheduler and then you schedule it. You put it on the schedule.
Oh, I see. That makes sense.
Yeah.
Okay. Note that a particular scheduler type may provide other kinds of scheduling operations which are supported by its associated execution resource, not limiting to use the execution schedule API. Okay. Um, Okay. Future papers, I don't care about future papers. Okay. Senders describe work. So this is where I need to pay attention. A sender is an object that describes work. Senders are similar to futures in existing asynchronous designs, but unlike futures, the work that is being done to arrive at the values they will send is also directly described by the sender object itself. So the sender object is the work itself.
Oh, okay, so it
So
is
something we
like
can try
futures.
here is, yeah, so what we can try here is we can explicitly ask this to be an, I think, std exec sender. Yeah, so this is a sender. There we go.
Yeah.
So we can explicitly require that interface, and let's just make sure the compiler doesn't cry about it. There we go. Okay, so this is a sender, which we're getting here. So the basically a sender is both the future and the work the future is representing at the same time. Why does this keep scrolling? That's not great.
It's kind of frustrating.
Yeah, wait.
We were like 4.6 or something like that,
Yeah, there we go for everything.
or 4.3 or something. Yeah,
Yeah, there we go.
yeah,
A
4.3.
sender is an object script. Okay. Primary defining sender algorithm is std connect. It's std execution connect. This function, however, is not a user-facing API. It's used to facilitate communication between senders and various sender algorithms, but the end user code is not expected to invoke it directly. The way user code is expected to interact with senders is by using sender algorithm. Faber proposed an initial set of such algorithms, which is described in 4.4. Hey, the next chapter. For example, here's how a user can create a new sender on schedule, attach a continuation to it, and then wait for execution of the continuation to complete. Oh, so something we can try. Let's go.
Okay.
So I'm gonna first format this. I'm gonna rename this function to main backup one, just to make sure that I have a backup. So let's make an actual new main function. Don't need arguments. Okay. So let's see, what does it want me to do?
You're up
Oh my
against
god,
it, but yeah, you gotta
yeah,
start at four,
scrolled
four,
again.
three, 4.3. Yeah, there you go.
Okay, so we need the thread pool. So I guess I can just use the static thread pool. So exec static, or exec static thread pool, and I want, let's say, just a single thread.
Yeah, because that should be a scheduler. By the looks of it, isn't
Yeah,
it?
so scheduler. So it's still like scheduler auto scheduler is the thread pool dot get scheduler.
So
There you go.
okay. Oh, okay.
But, I mean, they say that it doesn't have to be this function, but I want the scheduler, and that's what I got.
Okay.
So still exec sender auto sender. No, I can't read. That's send is equal xx schedule. There we go. And then we want a continuation. Do I do? No. Oh, it's another sender. So still exec sender auto. The continuation here is the exec then. There we go, then. So we want to start with the sender, and the second overload is what we want. So it's the sender, and then the function, which gets continued. So let's say I'll make a lambda here.
Is that how lambdas are
And
made in C++? Just a
oh
square
yeah,
bracket?
I'll talk about, yeah, I'll show you lambdas in just a sec. Let me just finish this thing, and then we can talk about lambdas for the viewers. I'm just gonna std print ln hello from thread pool. And let's make it personal hello midnight coders from thread pool and a semicolon. There we go. And then I want this thread. Wait. the deck sync wait.
Sync wait
Oh,
the
the
whole.
con.
Yeah.
Yeah, sync wait the continuation.
Is it continuation or
Okay.
context?
I mean, it doesn't. I think it's continuation. We attach a continuation to it. So that's the basics of
Oh, okay.
asynchronous, right? You do
Okay.
something and then you continue on something else. Okay, let's see if I can build it. Make it. Oh, I have a warning. I'm gonna respect all the warnings. Unused variable cont.
Oh, you
Are you
spelt it wrong.
stupid?
Did you?
I may not have saved the file. Wait,
Oh,
is
yeah,
that
save.
the save file issue? I
Oh,
didn't have a different error.
oh,
No,
bracket.
non-void error does not return a value. No, it's because my main
You
backup
need a.
doesn't return 0.
Okay. I thought it was because it didn't have a semicolon. Okay.
Okay, there you go. Builds no warning. And if I do main hello midnight color from the thread pool, let's go.
Nice.
Yes.
Okay.
Okay,
So
so lambdas are your question. Let's get.
just to step back on that. Is there not like an arrow function that like
Yeah.
that?
Yeah. Sure. There. So I'm gonna show you. So in C++, um, you need obviously we have lambdas, um,
Hmm.
and you need to declare them with var because they are a type in and of themselves, right? So they have an anonymous type. And
Okay.
I had a nice explanation for override of lambdas, and I think your viewers will appreciate it too. So remember how in C++ we are allowed to overload operators?
Yes.
So um, we can also overload operator parentheses.
Oh, Jesus.
Yeah, we can overload operator parentheses, hello from my lambda. And then I can make a lambda and call it with the overloaded operator parentheses. I go to build and make it and then run it to see hello from lambda. So basically, the lambda syntax in C++ is a shorthand for exactly this. So keep this in mind.
Okay.
So the structure with the overloaded operator parent. So we can instead do this. We can say auto lambda is square brackets. So the square brackets denote the capture list. I'll explain that in a second. Round brackets for the arguments, which in this case there are none, so I can omit them. And then curly brackets for the actual body. And here I just did print ln hello from lambda. So these two things which I wrote are identically the same and do obviously the same thing. So now if you notice, if I have an integer, I don't know, val equals 42 or something, let's say hello from lambda, the number is, and then I want to do val, you will see that I don't have clang D enabled. You'll see that it says the variable val
Okay.
cannot be
Ah.
implicitly captured. So by default, the lambda creates a new scope which does not have access to anything outside it. We need to be explicit about which local variables we want to capture. And for example, I can say I want to capture val, and then it works.
Okay.
And if I want to capture it by reference, I can do that too. And if I want to capture everything, I can just put that reference in here, and that's it. Now the thing is, if I do this, then that's equivalent of putting a basically integer val into my struct here, right?
Oh, okay. And
So this actually makes the lambda object bigger.
hmm.
And this is the same case in Java, by the way. If your Java lambdas are required to capture a million things because you have a bazillion local variables, you will allocate a lot of memory for that. So here, C++ lets us be explicit about what we want to capture, and we can put it here. If we don't, or if we want just the whole kitchen sink, we put the ampersand here, and we get it. And those are lambdas for you in C++. So the square bracket is capture list, and we have argument list, which in this case is empty, and then curly braces for the body.
Interesting. That's a little bit different than Java.
Yeah, simply the requirement that it's supposed to be as explicit as possible. Right, so C++ gives you all the flexibility, and it never, let's say, never forces you into doing stuff you don't want to do. Okay, so this is exactly what I did here. I created a lambda which just says hello midnight coded from the thread pool, and that's what it does. So lambdas, by the way, since they're anonymous types, they require you to use generics, which we're using generics here plentifully with the var keyword. Um, but I mean, maybe someday we will talk about generics in C++, which is one of C++'s most famous, most dreadful, and most difficult features, but also most convenient and fastest. Oh, someone joined us?
No, that was me giving you. I gave you staff right on Discord. Staff role, so you
Uh-huh.
have now you can see things. So you got a noise. Sorry.
Uh-huh. Okay. So there we go. Let's continue reading. We're at 4.4 again.
While you read that, I gotta run away for a quick second. Go.
Okay. So the primary is connect the K. We just did that. It works. Okay. Asynchronous programming often departs from traditional code structure and control flow that we are familiar with. A successful asynchronous framework must provide an intuitive story for the composition of asynchronous work, expressing dependencies, passing objects, managing object lifetimes, and so on. Right, so C++ is not garbage collecting. True power and utility of senders is in their composability. With senders, users can describe generic execution pipelines and graphs and then run them on and across a variety of different schedules. Senders are composed using sender algorithms. And there are three sorts of sender algorithms. Sender factories, which are algorithms that take no senders and return a sender, so basically constructors. Sender adapters, which take and potentially connect senders and return a sender. Okay, so it takes a sender, returns a sender, so it's an adapter. And then consumer is something which consumes. Okay. Senders can propagate completion schedulers. One of the goals of the executor is to support a diverse set of execution resources, including traditional thread pools. What is this? Okay, I don't think this. So this is like the completion scheduler. I don't really care about that. And okay. Execution resource transitions are explicit. The proposal does not contain any mechanisms for performing an execution resource transition. The only sender algorithm that can create a sender that will move execution to a specific execution resource is schedule itself, which does not take an input sender. This means that there is no way to construct sender chains that traverse different execution resources. It is necessary to fulfill the promise of senders being able to replace two-way executors which had this capability. We propose that for senders advertising their completion header, all execution resource transitions must be explicit. Running user code anywhere but where they define it to run must be considered a bug. That makes sense. I can't write code for the CPU and then have it teleport to the GPU. It makes no sense.
Can't teleport? Why not?
I mean, the GPU will throw you a seg fault because it doesn't understand the CPU instructions. It's like running x86 code on an ARM chip. It won't work. Some senders can be either multi-shot or single shot. They are forkable. They support cancellation. Okay, let's see if I can understand something about the sender factories, like how to use this. Just gonna look ahead for a second.
Yeah. Fuck that hurt. Oh, I just had to give myself insulin and that fucking hurt.
Facility and intuitive syntax for composition. Most sender adapters are pipeable. They can be composed or piped together with operator pipe. Mechanism is simple, similar to pipe operator in the range adapter support. Okay. Pipeable sender adapters take sender as the first parameter and have no other sender parameter. A pipe B will pass the sender A as the first argument to the pipeable sender adapter B. Pipeable sender adapters support partial application of the parameters after the first. For example, all of the following are equivalent. Oh god.
Jesus.
which it basically makes a pipeline. When do I get to coroutines? Oh, now. Awesome. Um,
You ask, we'll deliver.
yeah. Ask and you shall receive. Um, Standards represent a single unit of asynchronous work. In many cases, though, what is being modeled is a sequence of data arriving asynchronously, and you want computation to happen on demand when each element arrives. This requires nothing more than what is in this paper and range supported in C++20. A range of centers would allow you to model such input as key strikes, mouse movement, sensory. Oh yes. Given an expression R, which is a range of centers, consider the following in a coroutine that returns some generator type. So, wow. Oh my.
Koa wait.
So, what even is this?
Co
Okay, I
yield.
probably skipped over the stop test option. So, co-await is your usual await from most languages, right? That means the thing on the right has to be an awaitable, so something which knows whether it's done.
Yeah,
Co-yield is the
I'm just
same
used to
yield as
await and yield. I just think it's kind of funny. Koa wait for co-routine.
yeah, so the reason for that is that there is no syntax for an actual coroutine as a function. So the way that the compiler determines whether a function is a coroutine is it needs to look at its entire body and check whether there is any mention of the keywords co-await, co-yield, or the third one, co-return.
Mm. Okay.
So it actually makes sense in any case. The fact that this is awaitable though is very surprising. So let me see
That's
where. Okay,
okay.
so this did not appear yet. Okay, maybe I should keep reading. This transforms each element of the asynchronous sequence R with the function fn on demand as the data arrives. The result is a new asynchronous sequence of transformed values. Oh my, this is genius.
Mm. So now
Holy sh. Oh, this is beautiful. So, right, so in C++, your range can be generated, which is what this co-yield does. And basically, this generator here generates the thing which gets completed first. So then you take the thing which gets completed first. That's what's basically what the for loop does.
mm-hmm.
I have no idea what this means. Stop this optional. I hope we're gonna find this. Okay, let me just make a note here. We don't need this. So maybe I should do something like this. Um, let's say this is a big to do. Stopped as optional. Figure out what that means slash does. Okay. It's transformed. Okay, that's amazing.
Now imagine that R is the simple expression.
Yeah, this is all. Okay. Senders can represent partial success. Receivers have three ways they can complete. Success, failure, or cancellation. This begs the question how they can be used to represent the async operation that partially succeed. For example, consider an API reads from a socket. The connection could drop after the API has filled in some of the buffer. Cases like that make sense to report both the connection dropped and that data has been successfully read. Only in case of partial success, the error condition is not fatal, nor does it mean the API has failed to satisfy its post condition, merely an extra piece of information. Okay. In that case, partial success, another way of saying success, is a result sensible to pass both the error code through a value channel. Okay. Is there a reference or like just everything? Oh, there is a reference. Okay, let me then
Okay.
pop this open here. And I'm gonna need to zoom out. Let me know if it becomes hard to read. This is definitely hard to read. God damn it.
So you're looking for
Okay.
4.20.
Yeah, 4.20. That's the reference. User facing sender factories. Yes, that's what we need. Okay. Um,
If it's easier for you, middle mouse click on it and it'll open it in a new tab.
yeah, I know, but I'm just thinking whether it makes sense to jump there right now. Actually, no. Let's be patient and let's read this in order. I think I shouldn't let my impatience get the better of me. Let's do this properly.
Fuck that! I want to rip it. I want to rip this open and go at it balls deep.
Okay, so we saw that. This is all not that important.
We are going balls deep.
Oh, we went 2 balls deep, sorry. We were right about here. There we go. Senders can represent partial success, exactly. In other cases, partial success, partial failure.
Cold water. Let's go back to the knees. We shouldn't be balls deep.
Okay, this is what we want. All awaitables are senders. Mwah! Chef's kiss. Since C++20 added coroutines to the standard, we expect that coroutines and awaitables will be how great. What the fuck? We expect that coroutines and awaitables will be how a great many will choose to express their asynchronous code. However, in this paper, we are proposing to add a suite of asynchronous algorithms that accept senders, not awaitables. Yes, I was complaining about that. One might wonder whether and how these algorithms will be accessible to those who chose coroutines instead of senders. In truth, there will be no problem. Yes, because all generally awaitable types automatically model the sender concept. The adaptation is transparent and happens in the sender customization points, which are aware of awaitables. But generally awaitable, I mean types that don't require a custom await transform trickery from a promise type to make them awaitable. Okay, I see. So, okay. So there is something you need to know here. So,
I was going to ask you to
remember the
translate. I was going to
Yeah.
ask you to translate some of
So,
that for me.
so you know how we have a co-await in C++. So let me find it here in the documentation. Right, so we have co-await.
Yep.
So basically, this operator has two options. So either this operator is implemented by this thing, which then in that case this needs to be unawaitable, or this operator is implemented by this thing, by the thing being returned, in which case this needs to be accepted as a parameter to this operator.
Okay.
So basically, either the coroutine itself knows how to await something, or the awaitable knows how to be awaited. And the bridge
Okay.
between those two things is the await transform function. Right, so if the current coroutine promises the member function await transform, then the awaitable is promise.await transform of the expression.
Hmm.
Right, so it's the awaitable is either the expression, or if the promise knows how to deal with it, then it's promise's job to deal with it.
Okay.
And basically what they say here, fuck, it scrolled again. God damn it.
4.17.
4%. Thank you. You're such a lifesaver. 4.17. So what they say here is less
I,
than.
I thought it was
All
17.
here, it's 4.15. Yeah.
Oh, 15.
So
Sorry.
generally awaitable, so it means no await transform. Which means
Okay.
the awaitable needs to actually be awaitable and not be await transform, which is perfectly valid. The await transform really is a code smell, I'd say. Hey, for an example, imagine a coroutine type called task that knows nothing about senders. It doesn't implement any of the sender customization points. Despite the fact that the algorithm is constrained with the sender concept, the following will compile and do what the user wants.
Okay. You sound excited. You sound excited.
That is, oh my god! Since awaitables are standard, writing a sender-based asynchronous algorithm is trivial if you have a coroutine task type. Implement the algorithm as a coroutine. If you're not bothered by the possibility of allocation and interactions as a result of using coroutine, then there is no reason to ever write a sender, receiver, or operation state. I don't need to do shit. I can just write coroutines. Wait, is there a way we can try this immediately?
Ooh.
Do we have like some sort of task? Does the NVIDIA thing have a task? No, what?
Oh, you got to get Jippity to make you one.
Oh, there is a task. Hang on, yes, there is. Of course, NVIDIA got us. People be hating on NVIDIA.
I don't think I've ever hated on
Okay,
Nvidia myself.
I've hated on NVIDIA a lot of times myself, but now I'm
Mike,
loving them.
Mike,
It's a
Microsoft,
love-hate relationship.
Microsoft, I hate on all the time.
Okay. Oh yeah, Microsoft. Although there it is. We have found it, ladies and gentlemen.
All right. Your
Task
task,
and
your task is to give me a
my
coffee. Serve me a coffee.
okay string coffee. Okay, let's say struct coffee. What property should it have? Let's say a
Uh,
stud string
it should have a
name.
name of dark roast, and it should have,
Let's say
I
a
don't know.
double price.
Yeah, price is
So
doubled.
by the
Great.
way, by the way, something you should think about in C++ is a little bit of a learning opportunity um, for the viewers. Is you may think, well, float is good enough for me. Well,
Mm-mm.
because of alignment reasons, this is 24 bytes. Um, so this is aligned to 8 bytes. It means that if I do a float, I'll waste 4 bytes on padding. So I'll just use a double. Okay. So stud exec task of coffee. My coroutine. Oh, let's call it. I don't know. Let's call it cook. Co-return coffee of midnight coffee and have the price of 69,420.
That seems
Um.
about right.
Okay. So then.
Okay,
Um.
we have another task by a viewer. He wants a Red Bull with the flavor of awesome.
Red Bull flavor. Oh, I don't have a flavor field here. Relax. Um, let's just see. So we want the XX static thread pool, which is a thread pool of just one thread for now. I need to
No Red
return
Bull for
0
you,
at the
noob.
end.
No Red Bull for you, noob.
I'll do it
Sorry.
later. I'll do it later. Relax.
That's okay.
And
He's a
it
buddy
doesn't
of mine.
name Red Bull
He,
flavor is awesome. I
he's
mean,
a
okay, I guess that's
he's a
okay. Let's
buddy.
make an enum. Wait,
He's a buddy of mine.
enum flavor.
He's one of the
Yeah,
midnight staff.
flavor. Let's say the flavor is coffee or awesome. And then we have a flavor. Expected semicolons in them.
So
And
I guess
let's
instead of
say
coffee,
cook
this is now a caffeinated beverage.
coffee. Yeah, it has this coffee. There we go. And this should be a awesome, and this should be a Red Bull, and the price should be, I don't know, 42.69, whatever. Um,
Why is his
okay.
Red Bull
So
cheaper than mine? What?
okay, fine, I'll switch them. So let's do some Vim magic. Let's go here, do here, paste. There we go. There you go. Why is it not doing the thing? Oh, it's too long. Okay. Um, static thread pool, the thread pool. Okay, so what did it say? It said that I can stop scrolling. Oh my god.
Now you're on 416, I believe, or four. You were on
Yeah,
415, but
416. Yeah, 416.
I think we're on 16.
Says thing thread. I think we. Okay, so like all I need to do is send. So I need a sender receiver, right? So I need exec. Exec. Think weight of cook. Oh, there's an error.
An error. We don't like errors.
Because this for sure is Okay, so no await transform. It had an await transform for sender. Okay. Function cannot return function type static task. Are they scamming me? Maybe I need to say auto result. Oh, I'm an idiot. I need to call it. Yeah, I need the return value. Okay. So cook, please. And what is the type? Oops.
There it is.
Huh. Okay, let me do a little bit of reorganization here. This can go, this can go. There we go. Okay, hopefully it won't scroll. So okay, so auto result. Oh, Noob is super quiet. I can't hear him at all.
That's okay.
Yeah, I wasn't talking.
Oh, there you go. Yo,
The man
we're
came
doing
for
some
his
async C++.
man's not a
So
programmer.
this
He
is
just
an
came. He just
optional,
came for a Red Bull.
optional
Yeah.
tuple coffee. The optional stood tuple of a coffee. Auto result. Yeah. Shut up. Okay, nice. So the stud option. Okay, so stud optional. Okay,
So many
so
STDs.
we know that this optional is gonna be valid. So let's just stud println the coffee. We want the name, the price, and the flavor. Oh, I don't have. So unfortunately, we don't have a nice enum printing function. So let's say stud stream. No, so it's string, not stream. Print flavor of flavor.
Can't just
Return switch.
are enums not the
This
same
is
as
something maybe I should tell AI to do. So case coffee return coffee case also return coffee. Default
fantastic?
unreachable.
Okay.
The compiler will warn if we're not exhaustive. The coffee. That so the first thing is result. Does it understand?
Ooh. Is it
The
result
optional stud
value
tuple.
or what are we doing?
Oh, it's now.
Do you need to do result
It's
get
an
value or
optional of a. Yeah, but I can do the thing.
yeah value?
Not what I want.
Because I know that I usually hit with it with an
Let
optional.
me just see. Let me just do this. Coffee is equal to result. I know it's a value. So result. Let's see. Then get 0 of result. There we go. And that should be a reference. So the coffee dot name. There we go. Coffee dot price and print flavor coffee dot flavor.
Mm.
No reflection in C++. So you can't just print enums. You have to babysit it.
See, Java, I can do something that I can do like enum dot name, and it returns the name of the enum, like all caps, coffee.
Hey, can you show me that? Let's do a little bit of Java on stream. Why not?
Yeah, okay.
While I do the dirty work of adding Red Bull to this.
The dirty work of adding Red Bull. All right, let me.
It's all about the Red Bull.
It's all about the.
It's all about that Red Bull. All right, let me throw together a new Scratch file. Demo. Oh no, wait, it's Java. Sure, Scratch. Oh yeah, I'm not sharing my screen with you guys. At least I should do that so there's no latency. All right, now if I go why isn't it making it bigger? Oh, because I'm not in it. Okay, let's make that bigger. So if I had an enum of flavor, and I just sure we'll do that. If I wanted to come in here and say flavor equals, well, actually, you know, fuck it. I'll just say, yeah, for flavs equal flavor dot values. Probably could have just dot values dot this, but whatever. So flavs dot for each, and we're gonna. Really, you can't understand a for each? Fuck me.
What did he do?
All right, so I can just come in here and do
Oh.
this. Name. And if I run that bitch, why do I need annotations for that? There, chocolate, strawberry, vanilla. Like, all I gotta do is call it flav.name, like the enum reference.name, and it gives me the name. And
Nice.
technically I don't even need to do that. I can just call it flav, and very much so does the same thing. Prints out the names of the enums. So there's not a similar way to do that in C++.
Play that name. No. No runtime reflection, unfortunately.
Huh. Okay. Interesting.
You're gonna have gonna have to
So
manually implement that.
so that's why you
By
have
the
that.
way, we need to get another developer on here because, believe it or not, C++26 is also adding exactly this feature. And there's a guy in the C++ Discord called Che, who is extremely enamored with reflection, and he could do an absolutely banger talk on the stream. I mean, I'm gonna have a hard time convincing him to do that, but it would be amazing to have him on.
I think that'd be a great Dev Cafe topic if we can get him on to have a kind of an
Yeah, I mean, it
amazing
could be
discussion.
absolutely banger. I think he's just too big brain for it. He may say, "Fuck you, losers."
Well, if he's too
I
big,
mean,
if you're calling him big brain, then that's definitely it's definitely because to me
uh,
you're a big brain.
yeah, the bro is a huge brain. Okay, so what does this? What am I even getting back?
Noob didn't get his Red Bull. He left.
It cannot be the Kate Cup. It should move. Wait. Um, I'm gonna get the thingy. So auto val. This is what is it? Option tuple copy cup. Yeah, that's what I want. Third option
We have a
tuple.
we have a commenter, a live commenter asking us if that is Jas. Did you mean Bash? No, this is C++.
Yeah.
Roy had just asked that. Yeah, this is C++. We are exploring some of the C++ 26 features such as coroutines and um, um, that other thing that Prof is doing.
Yeah, it's still coroutines. Yeah. Don't worry about it.
Okay, it's all coroutine. Okay. Oh no, the guy.
No.
LOL. The guy is not Jas. He's asking who you are, I think.
No, the guy who was here was Noob.
No, the guy.
Yes, we got the coffee and we got the Red Bull.
Nice.
Nice.
Sweet.
Chef's kiss.
Noob, if you're watching still, we just served you a Red Bull. That
Yeah,
Red
there
Bull
we
was
go.
$69, my friend, and 42 cents.
Yeah, and we did it at the same time. Wait, so does that mean? Oh no, unfortunately, not. It's just gonna be run on this thread because okay.
Is there
But
a
we
way
could have
for you to
started it on two.
is there a way for you to print out the name of the thread that it's being printed on? Because like for me, I can just do something like thread.name or like whatever. And
Yeah, okay, I can
so
do that.
just so that I can like just so that our viewers can reference or see that this is
Yeah,
actually being printed. Yeah.
then this thread get ID. That will return a thread ID. There we go. Yeah, let's get.
Roy is asking if he can ask us for some career advice. Well, personally, Roy, I'm not actually in the field. I haven't been in a few years. I've got health reasons. I freelance as a developer, so I personally may not be the best one to give you some accurate career advice right now. What about you?
But yeah, go for it. Ask your question while I try to cook a little bit with the stud thread get ID. That's a good question you had for me, by the way, with the thread ID. I'm gonna implement that, and I'll get back to you.
Perfect.
While
Right,
you
so
answer
while
Roy
he's
Tick's question.
while he is looking at, or while he's typing up that, Roy, type your question out. Let's hear what your concern is, and we'll see what kind of advice we can give you. It's all right. That's all right. I'm not. I'm at peace with it. I'm at peace with the fact that I can't work, which is why I'm a YouTuber trying to teach and educate those who can't do. Teach. I can do. I just can't do at the same time. So.
Different means okay. So let's try get a static. 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 So there we go. Okay, exact traceable, deep pool. There we go. I want two threads. So they like schedule it. Auto pool. It's sketchy. Um. Oh. Can I do?
Just got into my second semester at university. I did a 6-month intern doing back-end dev with Java and Spring Boot. Actual work. This question might be up my alley after all. Java, I have over 20 years. With Spring Boot, I've got about 6-ish, maybe 6 or 7 years. Got 5+. I got 5+ with Spring. No, geez, yeah, no, I got 6+ because I was at web, and that was back in 20. I was at Newfold in 2019. Yeah, I've got like 6 or 7, closer to 7 years experience with Spring. Jesus Christ, time has flied, or time has flown.
Gotta work on that grammar a little bit.
Damn, where did you come from? Oh my god, holy shit. Red Bull doesn't give you wings. Red Bull makes you sneaky. What? Where did you? I thought you left.
I did.
Jeez. Now you came back and gave me a fucking heart attack. Oh my god.
Wait. No, 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 no. This is all going terribly bad. Um, also going terribly bad.
Honestly, Roy, while you're in university and still learning, it might be a great time to build your own sort of Spring Boot application that you can use as kind of a showcase um, for your resume, kind of like a flagship application for you, something that like for myself, if you take a look at my GitHub, I've got a bunch of different open source projects. One of my flagship things was actually something that I did a YouTube series on called the Midnight Technician, where I built this entire back-end Spring Boot microservice platform that consists of 11 different services that make up everything from a payment processing to schedule to employees to uh, um, service discovery, Kafka, and all sorts of fun. Um, I would definitely recommend while you're in school, focus on some sort of flagship project that can highlight all of your skills because once you get into the real world, you're not going to have as much free time as you will while you're in school. You'll learn very quickly once you come out of school that your free time is about to bottom out. You're not going to have any of it. So I would say while you're in school, while you're actively learning, while you have professors that you can question on deeper areas, I would start working on some kind of a flagship program that works for you and something that you can then take some pride in and make like maybe your sort of like public resume portfolio sort of deal. Um, I don't know if that's helpful advice, if that's just me talking to the wind for a little bit, but hopefully you find some sort of useful information in that advice.
The expression what? Yeah, no comment. Uh, word. What is wrong with you?
What did you do
Can it
now,
claims to
Prof?
complete on a domain that is not the domain of the completion scheduler? What? I'm not understanding this.
What's the LSP giving you the error for?
It said the static assertion failed, meaning the library is unhappy with what I'm doing. The sender claims to complete on a domain, it is not the domain of its completion scheduler.
The domain. Is that any?
How did they do it? Why is that different than what I'm doing?
You have async. Oh yeah, never mind. They got two.
Maybe I need to do static like then of this.
No, it doesn't like it either.
Okay, I have no idea. Okay, so let's do the thing which we kind of know worked. Just undo a lot of stuff. I probably need to read the documentation a little bit more. Undo. There you go. Okay. So I forgot the thread pool. So let's just see if this works.
Uh, it doesn't always take a whole lot of time, Roy. I know I built my Midnight Technician application, which is 11 services and fairly large. It took me about 3 months in total to build the entire thing, and I live streamed about 90% of it. Um, it's I mean, like yourself, a lot of things just sort of come natural to me when it comes to Java, but I've also been doing it for quite a long time. It's great to hear that they're coming natural for you with with little experience. That's phenomenal. Um, yeah, I would definitely kind of explore now that if you know how to do something like making auth systems and basic like a gateway for APIs and sort of a custom service, maybe try to explore something like making two services that communicate with each other, like make a website service that is just sort of a website that's just like a basic web page, and maybe see if you can get it to reach out to a back end service to list a bunch of products on a page, and then maybe see if you can make it so that once you fill your shopping cart, you reach out to another service to handle some payment. You can do so with things like the PayPal. Like for me, I used PayPal's API, and it was dead simple. And I can use their developer their developer sandbox to generate mock-up accounts and transactions, and uh, you can see if you can kind of because it's not so much if you understand how to build a microservice system. Because once you understand what a microservice is and that it's basically just a standalone small application, hence the name micro, it's a small service, it's a standalone application that does something. Um, you start to get the handle that it's just a whole bunch of one program talking to another program through either HTTP requests or even using something like gRPC where you're making more WebSocket connects, um, which might be might actually be another area you can explore as a Spring developer because like myself, I recently realized or learned GraphQL, which I have a video on my channel. It was a lot of fun to learn that I used to use a whole bunch of REST calls to make to build up my pages and my requests, and I had learned the hard way with my production website that I have on the go right now, midnightcoder.dev. Um, I learned the hard way that the microservice architecture is great and definitely optimal for cases like mine, but not always the best way to go when starting. Uh, fuck, where was I going? Yeah, I learned that when I build up some of my my website, I'm making full out HTTP requests to the back end, which is making maybe 4 to 5 different calls to different services, making what should be one round trip to a database turning into 3, 4, 5 round trips just to get the information that I want. And I'm pulling back all of the information when all I really want is a small little piece of this and that and this and that. So instead of ordering an entire tractor trailer worth of supplies and worth of data, I only need an Amazon van worth. So like it doesn't make sense to be getting all of that extra overhead. So I learned that with GraphQL, I can design a schema of what I want and then just make one call, one round trip, get back just what I asked for, nothing else, nothing less. And it actually makes things a lot faster. Um, I went from screens that took 1.2 seconds to load to taking, I think it's about 300 milliseconds. So like I've learned that it made things incredibly faster. Um, and my next thing I'm going to be learning is gRPC because I have no idea how to implement that, but I'm going to be learning at some point soon in the future. Anyway, where are you at, Prof?
I'm
what
having
are
a total fighting the assertion error.
okay.
So I need some senders. I need to be stopped as optional. Maybe this is where I need it. I don't understand it. What?
Hmm. Static assertion failed due to requirements. M error.
Send ramp. Why function not callable with the given arguments? Where in algorithm? It's fine. Function is not callable with arguments.
Wait,
Oh, so I don't need then.
okay.
Can I? Okay. Okay, I think we need to keep reading. I'm sorry. I'm just lost.
All right, let's keep
So
going.
yes, I understand that awaitables are senders, but I don't understand how to use my awaitable thing. Okay. So many senders can be made awaitable by using execution with awaitable senders. We will take a look at that, I hope. Okay. We have with the sender adapt. Okay, so there's a lot of stop. Catch the stop signal, map it into an empty option. Okay. All awaitables are senders. Okay, it needs another unhandled stop. Okay. It's compatible. Okay, so this is what I mean. User-facing sender factor. A sender factor is an algorithm that takes no senders and returns a sender. Schedule. Return the sender start page, describe the start of the task graph to the provided scheduler. Okay. Scheduler are represent execution. Right. So this is the scheduler and the sender. Sender is the creation of new task on the system thread pool. Okay. Execution just. Return the sender with no completion schedule, which sends the provided value. The input values are decay copied into the returned sender. Okay, makes sense. It just takes the value. It converts an object into a sender, which just sends that object. Just error, return the sender, which is just an error. Okay, just stop, return the sender with, which just stops. Well, maybe I need to use starts on. Come on. Too many braces. Good bueno. I'm just trying to figure out what adapter I'm supposed to use. It didn't need to be a function, not a curly. Can I just remove it? Yeah, that doesn't work. Okay, I'm gonna have to keep reading. It makes sense.
Okay.
Execution just read and follow that. Then a sender adapter, an algorithm takes one or more senders, which it may connect as parameters, and return the sender whose completion is related. Sender adapters are related. They are never allowed to submit any work for execution prior to the sender being started later. What the fuck does started mean?
Jesus. Fucking flashbang.
Why is it flashbanging me? Okay, I have no idea why I'm being flashbanged right now.
There we go. Whoa.
Nope. Still flashbang. This is like unreadable. Okay, a little bit better.
This is unacceptable.
It is what it is. Okay,
Redo.
execution continues on.
That's your daughter's ears.
Okay, so the sender is only started once it reaches a completion. Okay. Oh, that's cool. So return the sender screen transition from one to another. Okay. Then the sender is kind of task graph by the input. Okay, let. Okay, so this should be what I want. So just a sec. 420. Okay. So let us
420.
start one by one. So auto first work equals third starts on. Sorry. Starts on. It starts on the scheduler and then continues with cook. Okay, what is that? Can someone please tell me what it is? Oh my god, it's a expression. Okay. Again,
So,
the Lisp in my C++, I'm actually panicking.
A sex
Okay.
expression. What?
Yeah,
What I was
list
thinking.
That sounds
list
pretty
stuff.
fun. A sex expression sounds fun.
Yep.
Sign me up.
When all first works, second work.
My cat is crying like a banshee. Come on up then, dumbass.
Call count implicitly deleted.
There we go.
Copy constructor. That's fine. So that should mean that I could just do
My
this.
kitty cat wants to say
but I
hi,
can-
everybody. My kitty wants to say hi.
Okay,
Which
that
one?
does work.
Maya.
It's a
No.
suppression again.
Good
Si-
kitty.
The Siamese kitty cat. She's so loud.
Yeah, okay, it's another sex expression. Oh my god.
Sex expression. I'm liking these. Where can I get
You're
one?
liking the tenders, huh?
There's a lot of sex.
Well,
There's
apparently
sex.
StudExec went all.
Well, I'm learning that C++ has a lot of STDs and a lot of sex expressions. So it's a very horny language.
Yeah.
I feel
I
like it's
like it.
I feel like it's a very adult language.
Yeah, well, it's in an adult language, but not for those reasons. There's more adult features. Oh my god, that is actually cursed because there's even more adult features in C++ now that I think about it.
Oh
Oh
god.
shit.
There's more sex expressions.
You want to
and
see one of the. No, there are no more sex expressions, but there's more weirdness, let's say. Let me show you that real quick. So,
oh yeah.
since you want some C++ weirdness,
Let's get kinky,
just to
baby.
relax my brain for us. Yeah. So imagine we have a struct my type, and imagine that for some reason we have, let's say, a private function. I'll make it static just so I don't have to instantiate it, but it doesn't necessarily have to be static. Static void. I know do private thing, and let's say it's the print ln doing private thing. So now we can have a struct other type, which struct other type, and suppose we here want to have a public function is do thing, void call do thing, and suppose we want the other type to be able to call this private function. Well, then my type can declare a friend struct. So first we need to then declare the struct first.
Or are we making friends with benefits?
Other type, and then other type can do my type colon do private thing.
Oh no way.
Yeah, I need to do it the other way around. Sorry. Struct other type do forward declare. There we go. My thing do private thing, and let's make the static just so that I don't have to make an instance. And then we can do other type colon call do thing, and let's save it. Let's build it. Do it. Yeah, doing private thing. There you go. So in
Friends
C++,
with benefits.
yeah, friends can touch your private parts.
Friends with benefits.
Anyway, that's a tangent. Let's get back
Oh,
to
we're
scheduler.
C++ is such a sexual language. We got friends touching
Liking.
private.
Liking.
We got friends touching private parts. We got sexperts, which is like this little sex PR thing. Sex PR? Is that
Yeah.
a pull request? Is that a code for sex? You're gonna pull my request, friend? Oh my god. This is getting too X-rated.
Y'all are
Okay,
diabolical.
we gotta change subjects here. My mind is too far in the gutter.
I think we need to continue for another 5 minutes.
Oh God, noob! No, no. I've talked to your wife. You only need 30 seconds.
Yeah, you're right. Didn't know the truth got out.
I was bullshitting, but damn, you just admitted it.
Well, technically it's 37, so joke's on you.
Oh, 37 seconds. Okay. Damn.
That's a long time for some people. Anyways,
It's at that point where you just now starting to get out of breath.
okay, I don't understand the static assertion failed. Okay, let's keep reading then.
Okay, you've been sitting here kneading my leg for a while now, Cat. It's starting to hurt. She don't care. She's sitting here purring as she's like rubbing her head into my arm and digging those claws into my leg. Like, you are so freaking lovey-dovey, Cat. Yeah. Say hi to the people again. Say hi, people. Hello. My name is Maya. She's super beautiful.
Use a good kitty.
She's fucking adorable, but like she's digging her damn claws into my leg as if I was some kind of like pin cushion.
Mhm.
And then while she's doing that, she's like headbutting my wrist. I got my arm down beside me here on my armrest, and she's just headbutting and then this like such a cat, crazy little. Yes, you. You's a crazy little munchkin.
Okay, I'm gonna. So it says it's an error. Let's see what the compiler says. Hopefully, the compiler will spit out more informative error messages. Um,
Okay. What we got here?
Okay, there we go.
Static assertion. Oh, okay, it's way down.
That's.
Okay.
I mean, it's
Jesus.
thousands
Okay.
of lines of errors.
Okay. So.
Okay, so error. Static assertion failed. The sender claims to complete on a domain that is not the domain of its. So it's domain details scheduler domain type. So in instantiation of function template specialization, get completion domain type. Okay, so that's what I need to do. That get completion domain. Do we have completion domain? No, do we have domain here at all?
110 times we do.
What thing is this? 5 point something? Implementer side.
Is there anything for underscore domain?
That's a good idea, domain. Okay, that's what we want. Okay, why does this not work? What is the domain of an awaitable? Maybe that's what I need to look here. Okay, so wait, underscore domain, that was a good idea. Domain tag, and what did it say? Okay,
Jesus, that's hard to
domain
read.
and awaitable. Yeah, I don't know why the website looks like this. It's gross. Is there like a PDF of this?
You can export the website as a PDF.
Yeah. Let me see. Not PDF.
I have a. Oh, that is a PDF right there. That first one.
No, that's not the same thing. Oh, there we go. Save to PDF. Save. Whoa. Okay, there we go. Documents to the execution PDF. Okay, that's acceptable. And save it.
That is massive.
It's taking a while. It's 170 pages.
That's not too big. Not for a
Alright.
document.
Oh, do I? I don't even have. Okay, I just need to open it. So can I do like file code? Home. Can it understand that? There we go. Yeah, and there's PDF. Okay, nice. Did you know Firefox is also a file explorer?
You can actually do that with any browser, I believe.
Yeah. So I want the domain underscore.
No, underscore domain.
Yeah, underscore. Let me just look at the error I'm getting. Uh, so the sender claims to complete on a domain that's not the domain of. Oh no. Let me just take a very close look at the. Let me. There we go. At wrap. Not the domain of its.
What are you looking at? Because we're still looking at your browser.
I know. I'm looking at it. The sender claims to complete a domain that is not the domain of its completion scheduler. Okay, maybe this is something someone thought of. So let me just say std exec schedule coroutine on thread pool. And contain. Oh, this is I forgot about this. So big shout out to this guy. One of the biggest contributors to C++ standard, also author of many books. As you may see, his posts ended on September 22nd, 25, because he died of ALS very young.
Oh, shit.
But yeah, did a lot of work for this standard.
My cat's now sitting on my lap watching my screen like she's watching you. She's
Okay,
wondering
maybe
what
this is what I'm looking for.
Add a coroutine.
Maybe does the NVIDIA have any documentation on their std exec? Oh yes, they do.
They have docs, but do they have them on?
They have docs, but not for me.
What's in the developer docs?
Oh, we have examples.
Okay, okay.
Oh, let me then just clone this and let's go into the example. That's a great thing to do. So let me just yank that. Move you out of the way. CD. Let me know if this is big enough. Cloned. Get clone. Bam.
It's big enough for me.
CD. Alright, here we go. Oh, we have a clang and everything. Awesome. Awesome. Perfect. Nice. So, force
Dive into
parallel
exam.
scheduler. Dive into examples. Yep. Hello, Koro. Yes. Oh, sorry. Oops. Knock the mic. Coroutines. Yes, please. That's what I want.
Man got too
You're
excited.
being nice
Threw
to
the mic.
Yeah. Yeeted the mic across the room. Okay. So in this coroutine type, static senders are implicitly awaitable. Co-await. Started option. Oh, that's nutty. What? What are this result? LSP start. LSP start clanged. It's actually gonna work immediately.
Looks like it, I think. Why does it look like it's commented out? Like it's grayed out?
Yeah, it's a sense. Okay, I'm just gonna LSP stop it. The LSP doesn't understand anything, but we can grep or anything. I mean, I can just do This is, by the way, the power of grep. If you don't have an LSP, I can just do find word, and then I can paste that in. I can look for a define. If context per true. Oh, it's if still exact no exceptions. So if it doesn't want exceptions, okay. Awaitables are implicitly senders. But there's no scheduler here, bruh. Okay. IO Ewing. So they did my work for me. Nice. Oh my god, this is unreadable. What am I looking at? Okay, probably shouldn't jump right into this.
Jesus Christ. Why is C++ written so
You know what I can do?
Like I don't mean to harp on like one of your favorite languages, but why the fuck is it written so grossly?
I don't even know myself. Okay, they have literally no examples of coroutines on a executor. Okay, that's disgusting. But I have a second backup plan. There is another standard reference implementation of the same library. And this one is by your boy Mark Zuckerberg from Facebook. But it's less complete.
But it's less complete. Way to go.
But also we have async IO. Anyway, Okay, coroutine integration. Of course, it does have coroutine integration. Let us clone it and let's see what it says. Okay. Cd out of that. Git clone that. And so libunifx means unified executors.
Okay.
Okay, examples, yes. Oh, yes. So I want. Oh, that's a lot of examples. Nice. Async mutex. What even is that? Oh, they have a different implementation. Wait, did I not read this correctly? Media static. Okay, so stud exec things approved for the standard and generic additions and extensions are in exec. Okay. So that means exec is not a guaranteed one, I guess. Kind of makes sense.
Ah, excuse me.
Oh my god, I'm not understanding this. Okay, let me set my path here. Finally, await anything. Asynchronous sleep. Okay, holy shit. Hopefully this is helpful.
Okay. So delay schedule.
Turn schedule after. Okay, let's just go to the main function. Sync wait async main. Okay, it's not helpful. Co-await delay. Okay. Oh, that's how I'm supposed to do. Let me take a look at the reference here once again. Flashbang, sorry. So schedule after. Oh, so it's a timer. Is there anything else? It's one match. Uh-huh.
Rip.
Oh god. I'm starting to get fatigued from the C++.
Well, we
Okay,
have been
so
at this. We
one
have
last.
been at this for almost 2 hours.
Yeah. Okay, so one last attempt to get the schedule in a thread pool. So what do I do? Let's say let's make a. Let's just try and. How did they do it? That's what I don't understand.
Hmm.
I'm just reading the reference implementation once again. Can I actually do something like this? Cook auto exec scheduler auto reference scheduler, and then say scheduler dot schedule. Oh, so then I have stud exec schedule page, and I do a little bit of a co-await on that. And then what happens if I do a little bit of that? Paste it in here. Yoink this. Paste it on here. That obviously complains. Yeah, this is not good. Auto do stuff equals exec think wait of when all of Red Bull of the scheduler is SCH, and the other one is cook of SCH. And that's the
We really should have called the coffee one perk instead of cook.
What should I call it? Perk?
Perk. Yeah. Because it percolates. It doesn't cook. You percolate coffee.
Okay. Okay, I didn't know because I don't drink coffee.
We can't be friends
What?
anymore.
Me either.
Oh, you too? Oh, you're banned, noob. You're just banned again.
Again.
Yeah. So Noob and I have this ongoing thing for years where like he does or says something that disagrees with me, and I just ban him from whatever I'm doing, whether it be working on a game server, whether it be working on a website, whether it be just fucking around with my own thing. He's been banned. He gets banned from everything for doing anything.
Yeah. I've been
Oh,
banned like 9,000 times.
And for the record, he's a piece of shit.
Yes. Yep.
That's an insider thing. Yeah, he's that, and I'm a lazy dev.
Yes.
There we go.
If anything, I'm too fucking caffeinated to be a lazy dev.
Yeah.
What do you think, Maya? Just headbutted me. Okay. Even my cat knows I'm even my cat knows that I'm caffeinated.
Oh.
You're just gonna push into the mic. You gonna cry?
What? There's an error. Unused variable SND. Okay, I don't need it. Main. Okay, it worked.
It worked. Yay!
But it's the same thread.
It's the same thread. Why is it the same thread? Shouldn't it be run on different threads? Like in theory. Oh,
It's all the same.
Are you passing in the parent thread name? Or the parent thread, sorry? Like as the main thread?
I mean, I suspect I am. That's what I'm hoping to do here.
So that initial scheduler that you're passing in, is that?
Yeah, that's a thread pool scheduler.
That's the thread pool schedule. Okay, so the scheduler is the get the schedule.
Okay, I think this is not correct. Okay, well, we uncooked. Sorry, guys.
We almost had it. We were this close.
Yeah.
All right, Noob, come on. Red Bull gives you wings. We need to get that. We need to get that extra mile. Let's go.
Well, you see, I have no clue what you guys are talking about.
Zeros and ones do magical things.
You know what else does magical things?
Red Bull, that gives you
My significant other.
yeah, for about 30 seconds.
37.
37, right, 37. Well, that's your magical thing.
Okay,
That's
so
your
I'm
that,
looking. Okay, I have no idea. Okay, I'm gonna have to look at this again because maybe this is a bug in the implementation. But okay, no success for now. I'm too tired for this. Okay, so
all right.
note to self: we figured out how the library works. We have not figured out how it works with coroutines.
Mm.
Yeah,
Well,
okay, I have one last thing I do want to test. Wait. I do have one last idea I want to check out regarding reference implementations. So let me see if they have a task anywhere.
how would you like to FAFO tomorrow to fuck around and find out a little bit of Java, where I'll do something so that it'll be a TCP server, so you can just you'll be able to make a call from your end to my computer. I'll DM you the IP so you can connect to me.
I don't know. I have to take a look because tomorrow I'm actually rather busy, and even on Wednesday and so on. So I have to see.
Okay,
But
well,
today I was free enough to do a little bit of it. Okay, so I'm gonna next time whenever I get on, I'm gonna need to read this document apparently. Um, I missed it. Okay, well, good.
okay, well, I guess we'll wrap this up here, and we will continue the next time,
Be back.
and
We'll be back.
we will be back to mess around and find out. I've already said it this many times. We will be back to fuck around and find out uh, whenever Prof is available. Just so you know, Prof is going for his PhD. Let's give him a little love. Big brain gonna do big things. And that being said, we will wrap this up for the evening, guys. Thank you very much to everybody who has come and joined us. And if you haven't already, hit that like and subscribe button. Turn on notifications so you know when we go live again. And if you would like to actually join us live, join the Discord and you can jump in like Noob did and come say hi with us and chill with us, and we'll poke fun at you and treat you as a
Yeah.
true friend. All right, so as always, everybody, keep your curiosity open, your skills sharp, and that coffee cup full. We'll catch you in the next one.